Yeah, g'day YouTubers, Spannerman again here with another video. Hope you enjoyed the video today. Please subscribe to the channel. Any comments, thumbs up. Thanks for watching. Bye for now. G'day YouTubers, Spannerman here with another video. Today we're just going to talk briefly about chainsaw angles that you find on your electric grinder and how accurate they are. I can tell you from personal experience that I've got 10 grinders and I've only found 2 grinders that are slightly out. One's a fairly cheap one, only worth $100. I found that to be out a little bit. Not that it's going to be a dramatic change in anything, but nonetheless, with modern laser type equipment these days, you shouldn't sort of be having those problems. And I brought a steel USG grinder, and the head tilting angle 2.5 degrees out. Couldn't believe it. I sat it in a vise just like this one, and I'm looking at the head and I thought, that don't look straight. Oh, I thought, oh yeah, it's probably not on zero. Had a look, and sure enough, it was out. Little mark on the side on the steel USG. It has a little indent in the aluminium backplate. I had to put a new mark in there. I left the original one in there, and I tried to sort of like camouflage it with a little bit of paint so that it didn't stand out so much. And the new one, I put a bit of black texture in there so that it stands out. So hard to believe. What equipment did I use? This is the other problem. Be careful what you're using. So I've got some Mitutoyo equipment here. I've got a Mitutoyo combination protractor. This is worth a few $100s, so it's pretty dead accurate. And the straight edge, got to be careful that it's dead straight. You don't want to be using some sort of thin ruler. You run your eye down it because sometimes these have got a slight bend in them. So yeah, be very careful. Anyway, we'll cross that bridge when we get to it. And we've also got a Mitutoyo digital caliper, which has actually got NADA certification, so we know what its accuracy is on that one. So anyway, let's go back to this. I've done all the checks on this, and interesting enough, I done one on here because there was somebody was on YouTube, and he was saying how this was all out by about 2 degrees, and I thought, well, I've got one of these, and what he did was undid the little Phillips head screws, took the plate off, filed it, and slid it to the right direction that he thought. What I've done, you'll see a little black line there. We'll just zoom in there. I've etched that into the body, and that runs right in the middle. And reason I've done that is because the vise has a little bit of side movement left and right, and that's where you can get a bit of error. So what I did do to turn around and say, well, I know the scale's dead accurate, and we can sort of show you how that works. If this is sitting on zero, this guide rail has to be parallel with the back plate. So what I did was, we'll do it here, was measure this. It helps if you turn it on. So we'll just turn that on, zero it. Put it right on the edge. There's our reading there, 141.63. And we'll do the same on this side. $141.67. So you ain't going to get any more accurate than that. So what that's telling you is that this is pretty much perfect, lined up parallel with the back plate, and have a look at that there. That is sitting on 0. Now, what I will demonstrate is where this can be out a little bit, is that when you do loosen this, can you see that move from side to side? So when you move that from side to side, the rails will move a lot more. There's a lot more movement. I'd say those rails can move up to 2 millimeters. So the whole idea of this is, because that's 0, I like to make sure that the vise, the 0 mark, is right on the line because of the movement that you get in the vise. That's the only inaccuracy that I've found. So, okay, that's one thing. The scale is fine. I've checked the scale, and we'll show you how to check the scale. Another part that people check, and they find out they get mistakes, is that when you put this on 0, and we'll put that on 0, and you've got to make sure that the vise is lined up there. That's lined up all right. We'll just see we'll put a straight edge in here. So this is checking your alignment. When you pull this down into the grinding position, you want to make sure, I've got to go check the vise, make sure that it's dead on. Got to shine the torch under here and have a look. This wheel's used it's a little bit offset, so we're going to just move this a fraction this way. I'm just setting this up, and once I've got it set up, I'll explain it to you. It's got to go back a bit, just a touch. That's set up properly. Now I'll explain it to you. What you're trying to achieve here to check is that when you pull that down in the grinding position, the width of the wheel is approximately 145 millimeters. As that grinding wheel wears down, you will pull this wheel down further. When you do that, the center line, I'll just see how good you can see that. Hang on, let's just check. I'll zoom right in, and I want you to see it. I could probably go a touch. I'll just see whether that... Yeah, that's pretty much, depends. I'll just make sure I've got the camera in the right spot. So if I move the camera, that's about it. That's pretty much perfect. So what you've got to do with your eyes is make sure that you're looking not one side or this side. You've got to look dead square on. And the nut, the ruler lines up in the nut. And we'll just see whether you can see down here. What are we on? Let's have a look. Oh, we're a fraction to the left of the 0. As that wheel wears down, we'll end up going to the right side. So that's pretty spot on. Yeah, that's pretty good. Okay, so that's that measurement. That's something that you can do every now and then when the wheel wears down, you can make sure that you can put a straight edge in there, and you can check that and make sure that it's not offset. And if it is off a degree, or as it gets smaller, especially when wheel wears down about 10 millimeters off the wheel, you're going to be offset. You could be 1 or 2 degrees on the scale. You can also use that scale if you've got 10 degrees downward tilt. So let's just say you're 1 degree off. Then you would add that 1 degree on top of your 10 degrees, and you'd subtract that on the other side. So you'd have 9 degrees on one side, 11 degrees on the other side if you're 1 degree off. if you're 2 degrees off, you're going to be 8 degrees on one side and 12 degrees on the other. So, yeah, you might want to just write that down and keep a record of it if you're that fussy. If you're not that fussy, then don't worry about it. Just put it on 0. It's not going to be, it's not going to change things really dramatic. It's just if you want to be a little bit fussy. Okay, so the next thing is this other person has got his plastic, it's a bit of a angle gauge like this type of gauge. This angle gauge here is pretty accurately because all the markings are done by laser, so it'd be pretty spot on. And this would be the same as the Mitutoyo as well, all done by laser markings, so it'd be pretty dead accurate. What I've got there is a digital angle gauge, and if we sit the digital angle gauge up there, there it is, 0.1 of a millimetre. If we sit it down there, we're 0.3 of a millimetre or 0.2. You're not going to get much better than that. Okay, when you press the 0 button, it calibrates. So it's 0.1, 0.2, 0.3. No one's ever going to complain about that. Okay, so this person was saying that he's got over 2.5 degrees on this angle here, the tilting. And I thought, wow, I found it to be dead spot on. So we'll just put an angle on there. Let's take it to 60 degrees and do it as, line it up on the back here. Now, if I'm a half a degree out, I'm not going to worry about that. So as best as what I can see and line up, that's about 60 degrees. Let's see what it's like. Just hold it. Okay, 29.5. Need to turn it that way. 60.3. That's not bad from eyesight. I've just looked at the gauge at the back and lined that up and it's saying 60.3. That is pretty accurate. Let's take another one. Let's take 50 degrees. So these markings are quite big at the back. So as I said, I was half a degree off. That looks pretty accurate. Same sort of thing. It might be off half a degree. So it should be around about 50. Jesus Christ, it doesn't get much better than that, does it? Hey, look at that. How good's that? The other, what have we got here? No, I'm just trying to, hang on, why would it say 38? Hang on, let's try and figure this out. 40 degrees, 50. There we go, I held it the wrong way. So that's directly on the wheel, 50.4. I guess you've got to be careful because if you tilt it that way, you're going to get a reading from that angle. Yeah, because what that is, the reason it's saying that it's nearly 40 degrees is because that's 40 degrees from 90. So it's on 50, so 50 and 39 and 40 is 90 degrees. So that's why it's like that. So I don't think anybody's going to complain about that. And if we just do one more, let's just go halfway, about 55 degrees. I mean, you know, I'm just trying to get it, line these two things up perfect here. This person's saying they're getting 2.5 degrees out. I'm thinking, well, I don't know where you get your 2.5 degrees out. Wrong way. It's got to get it right. There we go. 55 degrees. Doesn't get better than that. So, what I'd like to say to that person, he was using some plastic angle gauge. This mold in here, all these would come out of the same mold in the foundry. So why you're getting 2.5 degrees out, I've just done 3 different measurements and I'm not even out a 1/2 degree. As far as I'm concerned, that's perfect. This scale, this one here was dead accurate. The only other one, it'll take me a little bit of time to set up. I can show you, just for those people that may want to see, I can set this up, tip this up on the bench and have this on 0, and I can show you that these graduations are spot on, and that'll just prove that the Tecumseh Jolly Evo, using the equipment I've got, I'm getting fantastic results, can't complain. The only thing that I did say was they could have improved on this vise. This vise, oh, if you zoom in, has got a little bit of side movement. You can see that side movement like that. So that's going to throw you off a degree or so, maybe a degree. And that's why I got the line there that I can look at it and say, oh yeah, there's left and right, I'll get it right in the middle. And that's as best as you can do. And I don't think anyone would complain about that. So what we'll do, we'll set it up and we'll show you how the digital angle gauge works on this scale here. And yeah, that proves that the Jolly Evo was dead accurate. All right, be back in a minute. Okay, back again, we've set it up. This is my method to check the scale of any grinder, provided, and most of them have got the steel rail. So if you sit the grinder up, 0 at here, make sure it's 0 here. So any which way that I tilt this scale will show me what the degrees is on the angle finder. This is, to me, the only way that you can reasonably do it accurately. It's probably done at laser. You know, when they first sort of check the scales, you'd probably use a laser beam. And this Klein digital angle gauge says it's got an accuracy of 0.1 degrees. So I tend to believe that it's probably pretty spot on. So because it can measure 0.1 of a degree, the numbers can float around a bit. So if we just go this side here and we have a bit of a look at it there, that's pretty much saying that it's 10 degrees. So the Klein's saying 10.5. You know, if I move it a fraction, yeah, so there you go. Let it settle down. That's pretty good. We'll go to 20 degrees. That's on the scale. I'll just see if that is. Yeah, look, that's pretty good. I don't think that's probably, let it settle down. Yeah, that's pretty spot on. So I'd say, yeah, it's pretty good there. Then we'll go to, say, 30 degrees, and that's going to be something like, yeah, let's get it fairly 30.4. Let's go back to, say, 0. Oh, sorry, that's 5 degrees. Yep, that's, I thought we were on 0. There you go. So that's spot on. We'll just go the other way. Let's try not get my head in the way here. Can't really see that good. Hang on, I'll just try and come around this side. I'm just struggling trying to see the scale, and what's it? Yeah, 9.8. Can't complain about that. And we'll just try and get it. Look, I'm just moving it approximately. It's, yeah. And then if we go, say, to the 30. As far as I'm concerned, that's pretty dead accurate. You're not going to get much better than that. And if we bring it back to 0.1. Now, you might turn around and say, there's people out there, there's always knockers, and they're going to turn around and say, oh, I think you're overdoing it, mate. You know, you're going overboard. My answer to them is, no, I'm not going overboard. I have found, like my Stihl USG grinder, to be out 2.5 degrees, and my friend over in Poland said that his is out 2.7. So I find that a really big mistake. And then I've heard other people say, oh, look, sometimes you get that on a machinery or equipment. It can be out by a couple of degrees. And I thought, well, yeah, if quality control's doing their job, that will never happen. The only reason that I'm doing this for myself is that if I'm using this grinder, at least I can say that it's within a half a degree. Even if it's in 1 degree, it's good enough. But I know this is good enough within a half a degree accuracy if I just take my time setting it up. And I could see with my eyes on the tilt of the motor, I could see 2.7 degrees out quite easily. So not that it's going to be a big game changer, but nonetheless, if I've got a piece of equipment and I put it on 10 degrees, I expect it to be 10 degrees. Same as if I put it on 20 degrees or 30 degrees. I expect it to be within 1 degree at least. Yeah, because it's not a digital scale. What we're talking about here is a numbered scale, and you rotate it according to the point. The point is not... if you have a look at the line on there, it's probably 1/4 of a millimetre or near a 1/2 millimetre line. So, you know, all you can do is go by your eyesight and put it on as best as you can, and who cares whether you're a half a degree out. But if your scale is out by 2-3 degrees, and then you're out by your eyesight a little bit, then you could be as much as 3-4 degrees out if you haven't calibrated and checked your own unit. Not everybody can. As I said, most people probably don't care about this. I'm just showing you that I've seen a lot of reviews about the Jolly Evo Tecamec, and people are saying that they're undoing the bolts, they're filing it, the scale's all out. I've just shown you that this scale is spot on. I've did it this way. I've measured. So the back plate's on the bottom. I've measured it to show you that this bar here is parallel with the back plate within a fraction of a millimetre, and it's really accelerated. When we've got 0 degrees here, and when we're measuring the distance at the end, the moment that you come out here, it's greatly amplified. So any mistake's going to show up once you move outside from the centre of this line to this outside here. It'll be greatly amplified because of the leverage. Anyway, look, I hope that helps. That's just on the accuracy of the Jolly Evo. As far as I'm concerned, it's got 10 out of 10. It's accurate. There's nothing wrong with it. They'll all come out of the same mould. So if people are measuring and saying theirs is inaccurate, I'd really be looking at the plastic equipment that you got. Don't be using these type of child's toys if you're going to be measuring angles. These are just there. All these little plastic El Cheapo things aren't that good. As I said, I use the Mitutoyo protractor. That's worth a few $100s. The Klein digital gauge. They're a very good, accurate piece of equipment. As far as I'm concerned, it's 10 out of 10. Thumbs up. Thanks for watching. Bye for now.